Yes, good afternoon, everybody. Today we'll be seeing, welcome to this session of transportation engineering. Today we'll be seeing design of highway vertical alignment. As I had explained you all the importance of horizontal alignment also. Basically, what is alignment? As I had told you, this is a center line which is marked onto the pavement so that the vehicles can travel at a better position. The vertical and the, as you can see in the introduction part, the vertical and the horizontal layout of the highway make up the alignment. As we come across flat terrains as well as some steep terrains also and some slope terrains also, and we have some mountainous areas also. So depending on that area, sometimes it is very difficult to come up with the alignment. We come across horizontal curves also sometimes. So at that position we try to mark as possible whatever is possible, we try to mark the horizontal alignment. But sometimes it is very steep or it is very narrow. At that times we have to go for vertical alignment also. Today we'll be seeing what is vertical alignment here. The design of alignment depends primarily on the design speed selected for the highway. As we had already seen what are the different, according to the speed, how the highways have been designated. We have expressways, and then we have the national highways, and then we have the state highways, and then we have the different district roads and the urban roads, and everything have been specified depending on the speed limits. As you know, the express highways, they have been given the speed limit as 120 kilometers per hour. So here what happens is the vertical alignment depends on what type of speed what is the design speed that has been selected for the highway. So it is a very important factor which is related to the alignment of the highway. You can see here the least cost alignment is one that generally takes the form of natural topography. See, most of the places it is not possible to get a plain terrain, but sometimes we get plain terrain as well as some slopey from some steep slopes also. At that time we have to go for some vertical alignment also, and whereas at some places where we come across some horizontal curves, at those places we'll have to change the alignment depending on the need. So often that is, so the least alignment, the cost can be reduced if we have a plain terrain. So often this is not possible, as I had told you, because designer has to adhere to certain standards that may not exist on the natural topography. So while maintaining the standards as well as coming up with an alignment is not that easy. So the designer or the design engineer has to maintain all these standards so that he can give up a good alignment. It is important that the alignment has consistent standards to avoid sudden changes in the vertical and horizontal layout of the highway. So basic need is basic concern. What is here is when the alignment is marked, or when an alignment is set up, we should see there are no sudden curves or sudden changes here. It is very much important. You can't just suddenly give a turn because what happens, we have seen in the horizontal alignment, what phenomena develops is when a vehicle is traveling from a plain terrain, and when it comes across a horizontal curve, a centrifugal force is developed. So at those places we have to reduce that centrifugal force, which we had seen in the previous class. To reduce that centrifugal force, we provide the super elevation where the outer edge of the pavement is raised slowly so that this centrifugal force can be reduced. If that is not maintained, then there are chances of skidding as well as overturning also. So it is very important. We shouldn't provide some sudden curves or sudden ups and downs which can lead to the accidents also. You can see here horizontal and vertical alignment should be designed to complement each other for safe and more attractive highways. As we know, safety is the biggest priority which we give here. So we have to give a very good alignment where safety is being given the priority, and whereas we get a good design also. You just can't take sudden curves, and you just can't go sudden transition curves or sudden extra widening cannot be given. So it should be decided depending on what type of highway, what type of design speed it is. You can see proper balancing of the grades of tangents with curvatures of horizontal curves and location of horizontal and vertical curves with respect to each other. As I had told you, the horizontal curves and the vertical curves, they should be properly designed. Sudden curves cannot be given. It leads to the accidents as well as it leads to big consequences also. So these curves should be provided very correctly here. Example on poor design is what happens if we don't provide it, if we don't provide good horizontal curves, and if we don't provide good alignment, what will happen? You can see here sharp horizontal curves placed at or near the top of crest curve or bottom of sag curve will create hazardous section of the highway. As I had told you, sharp curves and bends cannot be given. You must have seen at some places they even put danger boards also, and they highlight this. The road which is coming further, you have a steep curve also there, you have a steep ascent or a steep descent also. Even these are marked so that the driver is aware of what he'll be facing. So this is very much important. We come up with a very good alignment here. You can see vertical alignment. It consists of straight sections of highway known as grades or tangents connected by vertical curves. So vertical curves are connected with straight tangents. This is what is vertical alignment. The design of vertical alignment involves selection of suitable grades for tangent sections and design of vertical curves. So suitable tangents also should be selected. I'll tell you what is a tangent and how it is selected, and how are the vertical curves connected to the plane terrain. It is very much important. We should see where the ups and downs are maintained, how deep or how high the alignment should be lifted or the pavement should be lifted. It is designed in a very specific manner here. Topography of the area which the road traverses has a significant impact on the design of the vertical alignment. So topography plays a very important role in designing the alignment. It is very important. We should see what type of topography is. You just imagine if you come across a pavement where you have to lay a highway in a mountainous area. So in mountainous area, as you know, you will face you won't get a plain terrain at those places. You'll face big problems. So what we'll have to do is at those places we'll have to design it in a very different manner. At some places you have steep slopes, and at some places you have very big uphills also. If you come across the northern part of the India where you have to provide roads at a place where the city is located very much above the sea level, at those places you will have to provide some roads which will have an uphill task. So all this should be maintained properly, where it shouldn't be so sloped that the vehicle doesn't get a proper grip over the road, and because of the improper road layout or the road pavement laid, the centrifugal force might create a very big problem to the vehicle also. You can see a vertical alignment and grades. Grades affect the performance of vehicles, reduce speed, especially for trucks. You just imagine, I'll give you a simple example. If you come across a pavement in which you have to take your vehicle to some uphill area. Now what will happen if you provide a steep uphill? Now what will happen? It will be very difficult for the trucks to move at those places. You must have seen at some places where the trucks normally they carry a big huge loads. So what happens is, if we don't provide good proper alignment or proper grades, it will be very difficult for trucks to overcome those slopes. Maximum grades on highways should be selected to limit grade effect on vehicle performance. Now what will happen if we give very steep grades? Then that will affect the performance of the vehicle. So it should be designed very properly. Selection of maximum grade depends on design speed. As I had told you that the different types of speed for vehicles have different grades here. And the design vehicle also, you have, as I had told you, we have A grade vehicles also, class AA tracked vehicle and class A wheeled vehicle, as well as we have class B also, wheeled and tracked vehicle, and different vehicles have been specified. So depending on what type of design vehicle is, we'll be providing the grades. You can see 4 to 5% grades have little or no effect on the pavement. If the grades are only of 4 to 5%, you won't have much effect. Studies showed that speeds may increase up to 5% on downgrade. So what happens, you just imagine you have a flat terrain and suddenly you have a slope. What happens is speed is increasing here by 5%. You must have noticed this while driving your vehicle. The speed increases here to 5% and decreases by 7% on the upgrades depending on the percentage and length of grade. You must have felt all these. Sometimes you have a steep slope and sometimes you have an uphill road. So while going on the steep slopes, your vehicle moves faster, 5%. The speed increases by 5%. And whereas where it has to man over a hill, it has to move upwards. At those places, it might decrease by 7% here. You can see maximum grades have been established based on operating characteristics of design vehicle. So grades are established depending on the what type of design vehicle. As I had told you, we have wheeled vehicle also, we have tracked vehicle also, which is the heaviest, the tracked vehicle, class AA tracked vehicle. This is the heaviest vehicle which carries the maximum amount of load. Basically it is a military truck, and the amount of load which comes from through the truck onto the pavement is about 700 tons. So it is a very huge amount of load. Now just imagine this big truck has to maneuver a slope, or it has to maneuver uphill area. So what will happen? We'll have to provide a very smooth slope, whereas this truck can be maintained here. You can see the maximum grade vary from 5% for downstream side of 75 miles per hour to 12% for downstream side of 30 miles per hour. You can see the difference here when you are going to the steep slope, what is happening, and when you go over a uphill task, this is the difference. 70 miles per hour is going for the downstream side, and whereas the upstream side 30 miles per hour. You can see the 40 miles per hour. This is the difference here. Maximum grade should not be used frequently, particularly when grades are long and traffic include high percent of traffic. So we should try to avoid as number of grades where we can, so that easy passage should be given for the trucks. On low volume rural highways, maximum grades may be increased. So you can see a rural, first it is rural highway, and it has a very low volume. So we can provide maximum grades here by increasing 2%. When grade length you can see is less than 500 feet and roads are one way in the downgrade direction, we can increase it by 2% if these criteria exist there. You can see this is the vertical alignment here. You can see here the vehicles have come across a steep slope, so you should provide that slope in a very proper manner, so that this vehicle doesn't overturn. As well as after moving to the steep slope, it should be able to come across this uphill road also. It shouldn't be designed in such an improper manner where the vehicle cannot move upwards. So this happens sometimes. You must have seen this when big trucks and loaded with whatever materials are, they won't be able to they find it very difficult to come across to move over a uphill task. So here the vehicle vertical alignment should be designed properly. You can see here vertical curves. You can just see how the truck is moving it has to move across vertical curve. You can see it has to come across uphill area, and where the side distance is very small. You can see what is the side distance. At some places the side distance is also a very big factor which plays a very important role in designing this vertical element. You can see here the crest. You can see the crest, what types of vertical curves we have. Crest and we have sag also, where the vehicle has to move downward, and downhill also and uphill also. All these are the types of vertical curves. You have horizontal curves also. You can see here at the left side. Basically what is being seen here, what is the side distance the driver can see on the opposite side of the road. So side distance is a very important factor in designing this vertical and horizontal alignment. You can see summit and valley curves. What are they? You can see the valley curves. Basically this is that curves where the vehicle will move downward, and it is forming a sagging area. And whereas summit curve, you can see the vehicle has to move upward. The vehicle has to move the uphill area, and then it has to move forward. So valley curve is that in the which the vehicle has to move downward. Whenever roads or railways change gradient, a vertical curve is required to take traffic smoothly from one gradient to the other. So vertical curve is very important in connecting when there is a change in the gradient. When the two gradients form a hill, the curve is called as summit curves. You can see it is forming a hill. That curve is called as summit curve. And when the gradients form a valley, so when the gradient form a valley or a downhill area, that is called a sag or a valley curve is produced. So you must have understood what is valley curve and what is summit curve here. You can see vertical alignment and grades. Minimum grade depends on drainage condition of the highway also. So sometimes we also need to see what type of drainage is there, whether the drainage has been set up properly. We directly can't go for some vertical curves, vertical alignment where drainage is not taken into consideration. It is very important we should see how the drainage has been placed, because in the long run, in the future, what happens when it rains heavily, so if the drainage level is above the alignment, above the road, then there will be a very big problem when the water cannot be moved away from the pavement, which can be dangerous to the vehicle drivers also. So this should be seen. 0% grades may be used on uncurbed pavements with adequate cross slopes to laterally drain the surface water. So we don't have a drainage system here uncurbed, we don't have curbs here, so 0% grades should be given on these roads. When pavements are curbed, longitudinal flow should be provided to facilitate the longitudinal flow of surface water. So longitudinal flow should be given, water should be given some passage where the water can flow off from the roads, thereby maintaining, thereby the road can be maintained properly, as well as it can give a proper grip to the tires of the vehicle. Minimum that can be provided is 0.5%, you can see here. Let us see, used to provide gradual change from one tangent grade to another so that vehicle may run smoothly as they traverse the highway. So basically from one tangent, from one level to the other level, when we want to go for a highway, at those places we'll have to provide a vertical curve, thereby we'll have to maintain, we have to give the priority for safety of the vehicle. We can't give sudden curves, or we can't give sudden slopes or a sudden valley, it can't come across, so we'll have to design it properly. Usually parabolic in shape. Classes or types: crest vertical curves, as I had told you, vertical curves, different vertical curves are there. You can see sag vertical curves. Main criteria for design are provision of minimum stopping side distance. This is very important. The driver should be able to see the other vehicle which will be maneuvering it, or the other vehicle which is coming from the opposite side. That side distance should be very clear. It is very important. Adequate drainage should also be there. If drainage is not provided, the vertical curves, because you can just imagine here, you are providing a vertical curve and you have a valley type of curve. There, if you don't provide a good drainage system, there are chances of the water logging in that valley which we have provided there. Comfortable in operation, it should be very easy, where the vehicle owner can operate it very easily, and present appearance. It should have a good appearance also. See, appearance also matters. It is very important. All four criteria are associated with sag vertical curves. So this is under sag vertical curves. All these four criteria should satisfy. You can just have a look at this. We have type 1, type 2, type 3 and type 4 types of vertical curves. You can see G1 and G2 is placed there, P1, PV1, PVC, and you can see the distance between these curves as L, and E has been marked here. You can just see what is G1 and G2. These are the tangent grades in percent. So we have some tangent grades also, they are marked. What is the percentage of those tangents, that is seen here. You can see capital A, algebraic difference. You can see capital A is the algebraic difference between those curves. L is the length of the vertical curve, the whole vertical curve. What is the length? That is L. PVC, point of vertical curves. PV1, point of vertical intersection. Point of vertical intersection. You can see the curve is intersecting there. That is PV1. Okay, PVT, point of vertical tangent. So where is the tangent forming with that 90 degrees angle? Where is that tangent forming? That is PVT. So these are the types of vertical curves. As you can see here, type 1, type 2, type 3 and type 4 are there. You can see, let us see what is crest vertical curves. Conditions for minimum length. Now when spotting side distance is greater than length of curve, we have provided length of curve. If we have the stopping side distance is very much high, and when the stopping side distance is less than the length of the curve, we have different figures here. We'll be seeing it in the next slide. You can see here, you can just see here, you can see here, this is sag curve where G1 and G2 and everything has been mentioned here properly. As I had told you, L is the length of the vertical curve. How much should we provide? How much should we give the uphill? That is decided here, L. S is the side distance, and that is provided in feet. S is the side distance. Okay. H1 is the height of eye above roadway surface. As I had told you, we need to get a good eye view of the vehicles coming from the opposite direction. So H1 is height of eye above roadway surface. H2 is height of object above roadway surface. This is height of the roadway surface, and this is height of the object above roadway surface. If some object is coming or some person is coming, so we'll have to guess what is the height of this person and at what surface we are getting this height H2. G1 is slope of first tangent and G2 is slope of second tangent. PVC, point of vertical curve, and PVT, point of vertical tangent. As I had told you, PVC is vertical curve and this is vertical tangent. So this is how we'll have to provide a side distance crest vertical curves. You can see here, see in this figure also, it has been changed. Length of vertical curve is the same from one point to the other. S is the side distance has been taken into consideration. Capital H1 height of I above roadway surface, as we have told, this is the height which is above the roadway surface. H2 height of object above roadway surface. So this is height of the object. This is H2 is the height of the object which is above the railway roadway surface, and H1 is the height of I above roadway surface. You can see G1 and G2 slope of first tangent and G2 is slope of second tangent. PVC point of vertical curves and PVT point of vertical tangent here. You can just see here what are the formula given. If the stopping side distance is greater than the L which we have calculated here, what is the L minimum? Minimum this L should be there, 2s minus of root of 200 plus SQR into H1 plus SQR into H2 whole square divided by A. This is how the formula comes up, 2s minus 200 square root of H1 plus square root of H2 square by A. L is the length of vertical curve, S stopping side distance, SSD is equal to 1.47 is equal to 1.47 stopping side distance is 1.47 U2 plus U square by 30 into A divided by G plus or minus G. So H2 is height of the above road is 2 feet, at least 2 feet H2. G1 is slope of first tangent and G2 is slope of second tangent. A is the grades of algebraic difference, as I had told you, G1 and G2, it is a difference between the grades from where to where what has been allocated. PVC point of vertical curve, as you can see in the previous class, PVC is the point of vertical curve here, PVC point of vertical curve, and PV1 point of vertical intersection, wherever there is an intersection, PV1 will come into picture. PVT is point of vertical tangent, PVT point of vertical tangent. This is how the crest vertical curves are being analyzed. L minimum is equal to 2s minus 2158 slash A for if S is greater than L. This is the formula when S is greater than L. You can see here now L minimum when S is less than L. Stopping side distance is less than L. Now what is L minimum? AS square divided by 200 square root H1 plus square root H2 whole square. So this is how the L minimum when S is less than L. The formula is little bit same. Something from here to here has been changed. So you can see that change here. H1, H2 and everything has been mentioned in the previous slide also. L minimum is AS square slash 2158 for S is less than L. You can see sag vertical curves. Selection of minimum length of sag vertical curves is controlled by. Now how do we design the sag vertical curves? What are the factors that should be seen for designing of sag vertical curves? So this is the first one, side distance provided by the headlight. What is the side distance that is provided from the headlight? You must have seen here when we drive a car in the night time, the sudden vehicle coming from the opposite direction, he ons in the light or he has some light, when he comes close by, it is so heavy that even it might have some effect on us also. So side distance provided by the headlight. You have rider comfort also, the rider should also be comfortable. Control of drainage should also be seen there. General appearance, how does it look? It should have a good appearance also. You can see this figure for headlight, sun distance or sag vertical curves, and S is greater than L. You can just see here, this is the figure, headlight beam, and this is the place where the vehicle has the vehicle is there and the passengers are there in it, and the D point headlight beam is so high. So this should be seen. You can see when sag vertical curves minimum length when S is greater than L, L minimum is equal to 2S minus 200 H1 plus S tan beta. You can see here, please be clear here, it is S tan beta by A, S tan beta by A. B head of headlight is 2 feet, B is angle of upward inclination or the headlight beam. So that is 1%. Angle of upward inclination of the headlight beam, it is 1%. You can see L minimum is equal to 2S minus of 400 plus 3.5S slash A for S is greater than L. When S is greater than L, this is the final formula. What do we have? So when S is less than L, we have L minimum AS square divided by 200 into H plus S tan beta, and A square into 4 divided by 400 plus 3.55 for S is less than L. Stopping side distance is less than L. These are the formulas. You will have to remember this. These are important. Sag vertical curves. To provide safe conditions on a sag curve, the length of curve must be such that the light beam side distance be at least equal to SSD. So the length should be at least equal to stopping side distance. This is what they are seeing. So this is very important, that should be maintained, because there are chances when the children go onto the roads, or the passengers which is not driving properly, there might be very big chances of accidents also. The comfort criteria for design of sag curves require the both gravitational and centrifugal forces acting in combination. Yes, this is there. As I had told you, centrifugal force is created when a vehicle moves at a very high speed, and that can be seen at the horizontal curve when you come across that, because there are chances of the vehicle turning away also. Comfortable ride will be provided if the radial acceleration is not greater than 1 feet per second square. You can see here radial acceleration, if it is less than 1 feet per second square, we can see what is this challenge also. L minimum by comfort is equal to AU square plus 46.5. This is what U is the design speed in meters meters per hour. L minimum slash comfort is equal to AU square. AU is the design speed. 46.5, that is, we can get it also. We can see what is this also. Very easy formula. You can see here the drainage acceleration for sag curve is essential when the road is curved. When the road is curved, the drainage criteria is very important. It is very important for everything. You must have seen now the floods which had hit the Hyderabad. You must have seen many drainage passages which were made for drainage. They haven't received any notice, and they don't know what are the damages which will be caused. The maximum length is given there rather than him. To satisfy drainage criteria minute, grade of 35% be provided with 5% on level point of the curve. So this is also there. We have to satisfy the drainage condition as well as grade also. They should be maintained. Maximum length should be greater than minimum length for other criteria. For speeds up to 60 millimeter, 60 minutes per hour, you can see here it should be maximum than minute. Minimum length for a 70 miles per hour, 70 miles per hour. So 70 is the minimum length. 60 is what we have seen, and 70 is what you had seen in the previous session. The criteria of general appearance is satisfied by L minimum slash appearance is equal to 100 times of A. A is the area, 100 times of A. Now the L minimum for, let us check this now, this slide. Let us see from here. We had just seen these curves. As I had explained you all, we had seen till here. Let us see here. This was there. You can just see here. This is what we had seen. So when the stopping side distance is greater than L, we had seen this is the formula, and when the stopping side distance is greater than L, so 2S L minimum is equal to 2S minus 2158 slash A. You can just see here what we had seen. Yes, we had seen these figures also. 2158 by A for S is greater than L. You can we had already seen this also. Okay, anyway, when stopping side distance was less than L, L minimum is equal to AS square slash 200 square root of H1 square root of H2 square. What is H1? Height of I above road surface, that is 3.5 here. You can see here. H2 is height of object above the road. So the height of the object should also be above the road, that is 2 feet at least. G1 is slope of first tangent and G2 is slope of second tangent. Where are they meeting? Even that point will be seen here. A is the grades algebraic difference. So G1 minus G2, what is the difference? That is A. You can see PVC, point of vertical curve. Where is that point where the vertical curve is forming? That parabola, where is it find? Taking the curve. And PV1, point of vertical intersection, as I had told you, there is a point where it will intersect, and PVT is a point of vertical tangent. So we'll be seeing all this here. After applying the values, we'll get the L minimum, what should be the vertical curve here when the stopping side distance is less than L. That is AS squares divided by 2158. Let us see here. Now sag vertical curves, what are they? Selection of minimum length of sag vertical curve is controlled by. Now what are the factors that is controlled for designing of sag vertical curves? The side distance provided by the headlight. So the side distance is also is playing a very important role here. So what is the distance that is being provided by the headlight? Till where can we see? How far can we see? With the light we have on the vehicle. So depending on that, we'll be designing the sag vertical curves. The rider comfort. The rider should feel comfortable. It shouldn't be like that. The rider is not comfortable and he's having problems with riding, so even his comfort should be seen here. The control of drainage, as I told you, drainage should be provided properly, where if you don't provide the drainage, the problems have occurred, practical problems have occurred, and case studies has been done where the roads where the highways which were where expressways were made, and because of no proper drainage system provided, high amount of water had been stuck, had become stagnant there. Because of that, it had led to the blockage of the road also. You can see the general appearance should be proper enough for the design of sag vertical curves. You can see this figure in the next slides. For headlight sight distance sag vertical curve, S is greater than L. So you can see here S is greater than L, stopping sight distance is greater than L. At that time we'll have to provide a sag vertical curve in this way. It should be this. You can see here how the points are meeting and what is the intersection points and what is H and beta and L and D. All these have been mentioned here. You can see sag vertical curves with minimum length. We don't have a very big length. So at those times what we'll do when S is stopping side distance is greater than L. So L minimum, how much should be the L distance minimum provided? It should be 2S minus of 200 into H1 plus S tan beta divided by A. Okay, H is the height of headlight, that is at least 2 feet. The height should be at least 2 feet so that it can give a proper vision to the driver. Beta is the angle of upward inclination of the headlight beam, that is 1%. So beta is taken as 1%. You can see L minimum is 2S minus of 400 plus 3.5S divided by A for S greater than L. Please be focused here, because what is the S value, whether it is greater than L or less than L, that is more important here, and you will have to substitute the values here. When S is less than L, you can see L minimum, the minimum length of curve should be AS square divided by 200 into H plus S tan beta. Tan beta is the upward inclination angle, and S is we had already seen it in the previous class, what is S and what is A and everything. So L minimum will be AS square divided by 400 plus 3.5S for S less than L. It has been simplified and we have got this last formula. You can see here sag vertical curves. To provide safe conditions on sag curve, the length of curve must be such that the light beam side distance be at least equal to SSD, the light beam side distance. So it is very important we have a good light beam side distance, and it should be equal to SSD stopping side distance. The comfort criteria for design of sag curves require that both gravitational and centrifugal forces act in combination. So how should it be provided? As we are moving downwards, some gravitational pull is there, and in the vehicle when it comes across some horizontal curve or some other curve, centrifugal force is also being created. So we have to come up with some design where all these forces are managed in combination. Comfortable ride will be provided if the radius acceleration is not greater than 1 feet divided by second square. So comfortable ride is provided, it tells when the radial acceleration is not greater than 1 feet. L minimum you can see slash comfort AU square slash 46.5. Whatever the data we have given, and this is the recommendations we are getting from the IRC. U is design speed in miles per hour. You can see sag vertical curves. The drainage criteria for sag curves is essential when the road is curved. As I told you, when the road is curved, we have a different setup and we have a different types of vertical curves we'll have to design. It will different. The maximum length is given here rather than minimum. So maximum length is seen here rather than seeing what is the small length which is coming. We'll be seeing the maximum length from where the road has to connect to the vertical curves, horizontal curves, and what all is needed, that will be seen here. To satisfy drainage criteria, minimum grade of 0.35% be provided within 50 feet of the level point of the curve. So 0.35 should be provided at least here when there is 50%. So this is the minimum grade that should be provided. The maximum length is greater than minimum. Lengths for other criteria for speeds up to 60 miles per hour and minimum length for 70 miles per hour. So different speeds have been assigned for different speed limits, and depending on that the vehicle should be using those speeds also. The criteria of general appearance is satisfied by, for general appearance the criteria is L minimum by appearance is equal to 100A. You can just see here what all has come up, 60 and 70 miles per hour, but still there should be, we have to see different criterias, and then we should come up with an some formula. So criteria for general appearance is satisfied at L minimum is equal to 100A. Okay. Now what is the elevation of crest vertical curves? L minimum is equal to 2s minus of 2158 by A. We have already got that from the previous slides, and AS square divided by 2158 for S less than L. So this is a little change here. You must have seen A is not provided here. A is not important here, so it can be solved without that also. When S is less than L, L minimum can be rewritten as L minimum is equal to Ka. So it can be rewritten as L minimum is equal to Ka. Okay, fine. So after determining the length of crest vertical curve, we have this different elevations also, and the regular intervals can be determined. You can see this slides here. It is very important. It is simple. We won't require much of this. You can just see this layouts also. Please go through these figures. They are very important. I have explained you all of these. It is very important. If you go through these, you will understand how the vertical curves and vertical alignment is designed. You can see the elevations. These are simple curve equations. You won't find any difficulty in seeing all this. You can just go through this. Different curve equations have been given for what, when and where these curve equations are given. You can see for high turning point and crest vertical curves, as I have told you, where we come across very high mountainous area, how the crest vertical curves are provided. You just go through these formula. We'll be trying to do some problem also in the future. Then you can get a good clarity here. I request all of you all to please go through the session. It is very important, and please give your comments in the comment section. I'll try to answer as many questions as possible. Thank you. Thanks a lot.